I'm going to be talking about E-fields. E-fields are said to exist in a region of space around a charged object. Our charged object we're going to be talking about right now is a point charge, which exists in a three-dimensional plane, and you could think of the E-field extending out radially in all directions, such as this sphere surrounding this point charge. You can think of the E-field as being encompassed in this whole sphere and extending out in every direction. Now, the presence of an E-field can be found based on a test charge. So if I take test charge, let's say Q naught at this point here, and then say the distance here is R, I can determine the force on this test charge based on the formula Fe is equal to 1 over 4 pi epsilon naught Q times Q naught divided by R squared. And that is the force experienced by that test charge at this distance R. Now, if I wish to find the E-field at not for the test charge, but more at that position Q naught, I would say that the E-field is equal to 1 over 4 pi epsilon naught Q R squared. And this is for the E-field at any point given R. Now I'm going to go ahead and solve this problem here. This is going to be a square that has test charges Q, 2Q, 3Q, and 4Q. And my goal is to find first the E-field at location Q and the total force experienced by Q. Now first I'm going to go ahead and figure out what the distance is from 3Q to Q, which based on Pythagoras theorem, which is a squared plus a squared, which is equal to 2a squared. And if I take the root of that, root 2a squared is equal to a root 2. And that is the distance between 3Q and Q. Now to find the E-field, the E-field is going to be based on the force, or the field going in this direction, and this direction. So I can say that E total is equal to E1 plus E2 plus E3, which we're going to take is equal to 1 over 4 pi epsilon naught times 2Q divided by a squared plus 1 over 4 pi epsilon naught times 3Q divided by 2a squared plus 1 over 4 pi epsilon naught 4Q divided by a squared. And that is the electric field total experienced at position Q, which can be simplified to 1 over 4 pi epsilon naught times 2Q divided by A2 plus 3Q divided by 2a squared plus 4Q divided by a squared. And that is the energy total for the E-field total at position Q. Now the final part is to figure out what the total electric force is on Q. So I'm going to remove this. And we can think of it as the same way as E total. We're going to say F total is equal to force 1 plus force 2 plus force 3, which we're going to call force 1, force 2, and force 3. And this is going to be equal to 1 over 4 pi epsilon naught 2Q squared divided by a squared plus 1 over 4 pi epsilon naught 3Q squared divided by 2a squared plus 1 over 4 pi epsilon naught times 4Q squared. And now just simplifying that down, that's going to equal to 1 over 4 pi epsilon naught times 2q squared divided by a squared plus 3q squared divided by 2a squared plus 4q squared divided by a squared. And that is the force experienced by Q based on all these other charges on the square.